Looking at 2.2, there are some notes that I would like to start off with. So, vocab, additive inverses. So an inverse is basically the opposite. It can mean like the opposite, like in this way, or it can also mean 3 is the inverse of 1/3. They are also opposites and undo each other as well. But the difference here would be that this would equal 0 and this would equal 1. I believe these are additive inverses, and I think these are called like multiplication inverses, I want to say. I imagine we'll probably get to that at some point. Anyways, so that's the first part. We've kind of covered that before. And then the next one is additive identity. That's kind of messy. Additive identity. And that would be 0. This means that 0 added to any or to added to a number does not change the value of the number. So basically, the examples would be -7 plus 0 is still -7. And 1/2 plus 0 is still 1/2. It doesn't change anything. These properties will be useful as you explore subtraction problems with rational numbers. One way to think about subtraction problems is to take away objects from a set, as in this example. Kim had 9 DVDs. She sold 4 at a yard sale. She now has 9 minus 4 equals 5 of those DVDs left. One way to represent this situation is to use a chipboard, again, with the positive and negative chips, black and red, but this time these are all black and they just circled some and drew like this line to mean that they are leaving. Here's another example. Otis earned $5 raking leaves. He wants to buy a used bike that costs $7. His older sister put 5 black chips on the table to represent the money Otis has. So the value of his board would be $5. And then his sister asks, how much more money do you need? And he replies, I could find out by taking away $7, but I can't take away 7 because there aren't even 7 black chips on the board. His sister adds 2 black chips and 2 red chips. Is the value of the board the same with the new chips added? Why or why not? Because these are additive inverses. They basically cancel each other out. You can also use subtraction to find the distance between 2 points. The Arroyo family just passed mile 25 on the highway. They need to get to the exit at mile 80. And how many do they have left? So those are all examples for subtracting. You can use the number line to show this difference. Again, this is basically just showing the different ways that you can use these tools in order to figure things out for yourself. The last one is called absolute value. It says, In some situations, such as driving, it makes more sense to describe an overall distance without including the direction. You can find the arroyo's overall distance by taking the absolute value of the difference between the 2 points on the number line. You can write two absolute value expressions to represent the distance between 25 and 80. So the two examples they use these bracket lines for absolute value. It's just this straight line that extends basically the length of your binder paper line. It basically just needs to be bigger than your numbers. So 25 minus 80 and 80 minus 25. So you can see if you did 25 minus 80, you would get a negative answer, whereas 80 minus 25, you get a positive answer. But because they are in these absolute value brackets, it basically means that it doesn't matter if it's subtracting, if it's going to be a negative or a positive answer, the number is still the same. So you can evaluate these two expressions to show that the distance between points 25 and 80 on a number line is 55. So this would be negative 55, and this would just be 55. But regardless, they still have 55 miles to go. So when a problem says what is the absolute value of something, they just want the number. They don't care about the sign. I'll write that down. They just care about the number, not the sign. Positive, negative. For some reason, I always liked absolute value because you didn't have to worry about if it was positive or negative. I felt like that always made it easier to me. So looking at part A, it says, Benjamin takes $75 from his savings. So we're starting at $75. He goes shopping for school supplies and has $35 left when he is done. To figure out how much he has spent, he draws the following number line. So he has a number line, and he starts at 75 and has this arrow going back to 35. So number one is, how much has he spent? That's easy enough, right? If he started with 75, so you go back 65, 55, 45, 35. So he has spent $40. And number two, how should Benjamin label what he spent to show that this is money that he no longer has? So this would be kind of like your idea. Normally, I would have you work on this and then show your friends, and then we'd move on from there. But so I guess I'm hoping that you'll kind of think about this and think about how you would show that he spent $40. But I mean, I guess that's not like like you could be using colors and stuff. You could say, like right here, you could show like minus 40, like you could do that. Or you could Like how I did the bunny hops, you could do like -10, something like that. You could draw this like line being red, something like that. All of those things would work. So my answer here would be that. And yes, you can do stuff like that too, as long as it's clear. I'm going to move on to the next page. This is 2.2, part B. During a game of Math Fever, the Super Brains have a score of -500 points. Earlier in the game, they incorrectly answered a question for 150 points. However, the moderator later determined that the question was unfair, so the -150 points are taken away from their score. So number 1 is, will subtracting -150 points increase or decrease the Super Brain score? Explain your reasoning. So if they are starting at -500 and they lost 150, right? You could also do the plus and then have that. That's the same thing. Then they are going to end up with -650 points. And so their question then is, if you started with -650 points, could you, it says, will subtracting -150 points work? Will it increase or decrease their score? And you have to explain why. So this is the important part about reading it correctly, is that it says, will subtracting -150. That's two separate things. Remember, action, adjective. Will subtracting this number from this make their score go up or down? So what you have to remember, again, is that these two things cancel each other out. So you're going to be left with 650 plus 150, which is going to make it go up. So it's going to bounce them back to the original -500 score. So it will undo what has been done, which is the point. Number 2, what is the Super Brains score after -150 points are removed? I already answered that. It would be -500. And then write a number sentence to represent the situation, which I already did here, and show it on a number line. I did not do that part, so I'll do that part. So I'm going to do it down here to give myself some more room. So if I'm here at -500, they lost 150 points, so went back this way, 150 points to -650, right? But then they undid that. They went from here. They're like, oopsie, just kidding, back up here, which is going to land you right back here. So however you want to draw that, that's like my best drawing situation. But if you want to draw that a little differently, especially with colors, that would probably be helpful. And then we will pick up with part C tomorrow.